Hello student, welcome to EPG Pathshala. I am Dr. Guresh Kumar from ILBS. Today we are going to discuss about a module that is research inference and various statistical tests under the paper molecular therapeutics. The objectives of this test. The inference can be drawn by applying an appropriate statistical test. The various tests applied we will discuss today, and we will learn which test is appropriate in the research. Say for categorical versus categorical test, a chi-square test or Fisher-Jet test is inappropriate. The categorical versus categorical or paired data McNamara test is applied. Or categorical versus continuous data, it depends upon the level of the categorical data. Whether if it is 2 level, then t-test, pair t-test is applied. If it is more than 2, then ANOVA is applied, followed by a post-hoc comparison. If the variable is continuous versus continuous, correlation or regression analysis as deemed fit will be used. This is the objective of this. Then the various statistical test depends upon the nature of the variable, and in the descriptive methods applied here will be, first of all, tables. Everything should be represented in nice tables. Then diagram, because diagram gives you an picture of the data, whereas summary is also included. These are the 3 methods which by virtue of which we can explain the statistical things. There are 2 inferential methods. First is by estimation. Estimation means we want to estimate something. Third one is hypothesis testing. Hypothesis is nothing but a particular statement regarding the research project. In estimation method, there are 2 types of method: point estimate, like mean of the data or proportion of the data. The second one is the interval estimation. Interval estimation gives you the 95% CI of the data. So this comes under estimation. In estimation, we estimate, we calculate from the sample side. This is called estimation. Just simply it gives you one value and the prevalence of that. Whereas in hypothesis testing, we have the comparison between the treatments, comparison between the two or more various methods, association between the variables, etc. is seen by applying the hypothesis testing. Procedures and steps. First of all, to do any statistical analysis, we have a problem. Find the type of the problem and the question to be answered. That is the topmost, that includes the title and the objective of your study. Then we fix the level of significance, that is alpha, usually taken as 5%, and the power of the test taken as 1 minus beta, which is generally taken more than 80. State the null hypothesis, which is of no difference. Then next is state the research hypothesis, that is known as H1. Then select an appropriate test, either it is a t-test, f-test, chi-square, correlation, regression, like. Then take a decision whether it is significant or no. It depends upon the calculated value. If the calculated value is more than the tabulated value, then we say P is less than 0.05 significant, and then it is considered as significant. Make the inference accordingly by rejecting the null hypothesis. There are 5 such steps. First of all, state the null hypothesis, H node and H1. Then state the level of significance, generally taken as 5%. Alpha power, as already explained. There are 2 types of tests conducted in statistical life. Hypothesis testing, 2 types of tests are used based on the nature of the data, and also it depends upon the sample size. If sample size is adequately large, say more than 30 or even more than 60, we we have to apply parametric test. What do you mean by parametric test? It is the defined as when the distribution of the variable is known and it is distributed approximately normal, that may, and also it follows underlying assumptions. Then we need to apply parametric test. Parametric tests are generally taken as t-test, f-test, correlation or Pearson, or regression analysis. Some these are called parametric tests. Non-parametric tests are those tests when the distribution of the variable under consideration is not known. That means the data is not either the data is not normally distributed, that means it is highly skewed, or does not meet with the underlying assumptions of normality. Then the test we have to apply non-parametric test. It is also known as distribution free test, and when the sample size is very small, say less than 30, we need to apply non-parametric test. Non-parametric tests are Wilcoxon, Mann-Whitney test, Kruskal-Wallis test, or Friedman test. These are the called non-parametric test. Assumptions for parametric test. First assumption is the samples are random and independent of each other. This is one of the most important assumption which one should have. The independent variable is categorical and contain only two levels. For parametric test, distribution of the dependent variable is normal. This is another assumption which one should have. If it is not normal, apply some log transformation, something like that, to make it normally normally distributed approximately. Then third, the variance should be equal in all the groups. These are the three main important. First is random and independent of each other. Second, the distribution is nearly normal. Third is the variance skewness between the various groups should be same, equal. Then to analyze the B, it depends upon the variable taken at a time. Suppose we are considering one variable at a time, then it is called univariate analysis. If two variables, say age and sex, are taken together, it is called bivariate analysis. If more than two variables taken at a time for analysis purpose, then it is known as a multivariate analysis. So generally a univariate test or bivariate test are confused. But univariate test is that test where one variable is taken at a time. Univariate test, that means only one variable. It also depends upon the nature of the data. Either it is a categorical data or it is a quantitative data. Categorical data, as I explained earlier, has no measurable scale available. Some qualities are invested into it. That is why it is called categorical. Whereas in quantitative data, it is measurable. Some scale is present to measure. Then we call it as quantitative. For categorical data, frequencies, percentage, prevalences, incidence are calculated along with the 95% CIs. The graph which is generally made for this type of categorical data is either pie chart or bar chart. Whereas in quantitative, means, median, standard deviation, range, IQR, etc., so on and so forth are calculated. The graph generally made is error bar, box plot, a line chart. These are called quantitative. In univariate, one variable is taken as at one time. There, if we consider two variables taken together, then it is there will be three type possible combinations are possible. First is categorical versus categorical. Second, categorical versus quantitative. Third, quantitative versus quantitative. All the test depends upon this type of comparison. This type of when we consider two variable, it is known as bivariate analysis. If the data is not normal and we want to have, and the sample size is more than 30 say, then utmost try should be applied to have it normalized by taking some suitable transformation like log transformation, taking under root, something like that, so that the data can become normal as it is clear from the continuous data. If it is normal distribution, go and apply parametric test topmost line. If it is not normal, transform to normality. If it becomes a normal, then again apply parametric, otherwise apply non-parametric test. As I explained, if there are two variables are taken together, then the situation is different. First of all, as I explained, if it is categorical versus categorical in nature, and say x is one variable, y is another variable, both are categorical, then chi-square test or Fisher exact test has to be applied depending on the sample size. Or if any one of the cell is not is less than 5, expected value of the cell is less than 5, then we apply Fisher exact test. Then again, if it is categorical versus quantitative, if we are talking about parametric test, or then x is equal to having two variables and y is normally distributed, then again question rises whether it is a paired or unpaired. Unpaired is generally also named as unrelated. Paired data is also known as related sample. If it is unrelated, student t-test has to be applied. If it is related, pair t-test is the best option in parametric sense. If it is not parametric, non-parametric test is there, two variables are there, and y is not having normality conditions satisfied, then for independent sample or unrelated sample, we have to apply Wilcoxon rank sum test. If it is related or paired, then Wilcoxon sign rank test is the best option. Now this is for when we have got two levels. So this is the categorical variable and quantitative variable. And then sometimes it is not so. The categorical variable has got more than two levels, and y is assumed to be a normally distributed. If it is independent sample, one-way ANOVA has to be applied, one-way analysis of variance has to be applied. If it is related, then repeated measure analysis followed by some post hoc comparison is required. If it is take the case of non-parametric test, x is having more than two levels. Unrelated, for unrelated we have to apply Kruskal-Wallis test. For related we have to go for Friedman test followed by probability adjustment if it is significant. Now first of all, categorical versus categorical explained. This is general form of, this is done by applying chi-square test. What is the null hypothesis there? Null hypothesis there that observed values are same as expected value. So chi-square is equal to summation of observed frequency minus expected frequency whole square divided by expected frequency, where summation goes from 0 to n. N is the degree of freedom, number of cells, n is the basically degree of freedom. What do you mean by degree of freedom? It is the independent constraint, and in case of chi-square we have n degree of freedom is equal to number of row minus 1 into column minus 1 in if the data is represented in the tabular form. Chi-square test can be seen by applying this. But what it does give, it gives the association between the two categorical variables, situation, random sample of size n from the normal population, qualitative with two or more levels, assumption not more 20% of the expected cell frequencies are less than 5, and no expected cell value has less than 1. Then applying the chi-square is equal to 1 summation 1 to RC. R is the number of rows, C is number of column, summation of OI minus EI whole square divided by E with R minus 1 into n minus 1 degree of freedom. Representation of chi-square in the tabular form is represented like this. It is number of rows and number of columns. This is now the term expected value has come. How to find a expected value in the chi-square tabular in table? Suppose we are look at the table. Group 1, there out under outcome column, N11 is the first value. How to calculate the expected value of this observed N11 value? So what we do, we have the marginal total of group 1, then multiply these marginal totals, say n1 dot multiplied by n dot 1 divided by the grand total, that is n dot dot. So we will get the expected value E11 by multiplying the marginal totals dividing by the grand total of the table. So we will get the particular expected value. Like this we can have all the expected value, and applying the chi-square as shown the table, n11 minus E11 whole square divided by E11, like this we can get the chi-square value. And look at this chi-square value at the table, or nowadays computer has come, automatically it gives the p-value, so you can take a proper decision whether the H node has to be accepted or rejected accordingly. Statistical inference example is given here. Somebody is interested to buy vehicle, car, truck, bus or van. This depends upon personal choice of this. So here it is a column: car, truck, bus, van versus yes or no. So this is OI minus EI. I got p value as 0.001, which is significant. Only there is a 99.9% chance of being true. So this we say we reject the null hypothesis. So it means statistical significance means probably true, not by chance. So if p value is equal to 5%, that means chance of being not true is 95%. Chances of being true is 95%. 5% chances of not being true, or 95% chance of being true. That is what mean by p is taken as 0.05. If p is taken as 0.001, means there is almost certainty a true difference in purchase of particular brand X by owners of different vehicles in the population from which the sample was drawn is 1 by 1000 by chance only. It is not true. So it depends upon the preference, particular brand which they choose. Comparison of two independent proportion. It is 2 by 2 table. This is the form chi-square with 1 degree of freedom is n into AD minus BC, modulus of that minus n by 2, n is the grand total, the whole square of that divided by R1 marginal total of row 1 into total of row 2 R2 into total of column C1 to total of column 2 C2. This way we can get the chi-square. This is for 2 by 2 table only. Then hypothesis testing, comparison of two independent proportion. Suppose we have got two different samples, say city 1, city 2. I want to know the malaria prevalence or incidence of malaria, or say chikungunya. Then we have to apply jet test. which is equal to P1 minus P2 divided by P cubed 1 by N1 plus N2 in brackets. This gives you the Z value. If Z value is more than 1.96, we consider that it is significant. Otherwise, we say there is no significant difference. Here, what do we mean by P? P is calculated as a combined overall prevalence N1 into P1 plus N2 into P2 divided by N1 plus N2 bracket. And Q is nothing but 1 minus P of that. This way we can compare the two proportions. So here test is Z test. Now I will discuss parametric test for means. In case of categorical data, I have already explained we have to go for either chi-square or Fisher-Exact test depending upon the cell frequency expected value or the expected value of that. Now I will discuss how to compare various means. First, if only one sample is there, then we can apply a single sample t-test, that is called one sample t-test. Second, if there are two means, then it is known. Then if there are two means, then we can have two sample t-test or independent t-test or say student t-test. If it is more than two, then one-way ANOVA, more than two samples, then one-way ANOVA followed by post-hoc comparison is to be applied. Then if it is a one sample t-test, what are the various assumptions? That means they should be independent to each other or normally distributed. That means equal variance or unequal variance should be there. Then t-test for paired observation, that means if it is correlated, then paired t-test has to apply. Now question, this was all about the categorical versus categorical data. Now we will talk about the parametric test. First of all, one sample t-test. What we have got a sample, we want to compare with the reference. So this is the example. By applying sample mean, you take the mean of the sample which you have got minus the assumed mean, hypothesized mean, say it is equal to 14.6 divided by standard error of mean which of the sample, we can get the test. This is the t-test for one sample t-test also. Here the t is equal to minus 1.53. The degree of freedom will be n minus 1. There are 10 observations, so the degree of freedom will be 9. So we can compare it from the tabulated and reject accordingly. T-test for independent means of two groups. That means categorical variable has got two levels only. In which situation it is applied? Two independent random samples from the two different population with mean M1 and M2. What is purpose? I want to compare these M1 as with M2. What are the various assumptions under this? Distribution of the continuous variable with M1 and M2 should be nearly normal. That means it should be normally distributed and the variance should be same. But nowadays this assumption is not so stringent these days, because if it is not equal, then modified t-test is available also. Then what is the assumption? The sample, they are randomly sample distributed. So example, now we have got two sample, so independent sample, we want to compare two different means. Here it is a case of qualitative versus categorical. Categorical has two levels, non-smoker mothers and heavy smoker mothers. So here we have to go for t-test depending upon whether it meets with the normal t-test or not. A study was conducted to compare birth weight of the children born to 15 non-smoking and 14 heavy smoker mothers. These are the readings. The non-smoker mothers have These are the readings. Now we want to compare. The t-test is equal to x bar mean of the non-smokers minus mean of these x2 mean of the heavy smoker mothers divided by pooled standard deviation under root 1 by n1 plus 1 by n2. This is standard error of this, where s square is equal to n1 s1 square plus n2 s2 square divided by n1 plus n2 minus 2. This way we can calculate the t-test. Example, here it is explained in this. First of all, we will check the normality. This graph is drawn by plotting the histogram. And we find that it is nearly normal in the first case, and heavy smoker they are also nearly normal, though flattered one. You can go for t-test. If you look at the p-value, it is 0.02. It is less than 0.05, so we say it is significant. But that here the null hypothesis will be the heavy smoker mothers has got the same baby weight as equal to non-smoker mothers, this thing. But here it is significant, so we reject that. So conclusion will be the difference between the birth weight of the children born to non-smoking and heavy smoking mother found by chance only in 2 out of 100. So it is accepted, we say both the weights are different. That means baby born to heavy mothers, smoker mothers, is different to the non-smoker mothers baby. The birth weight of the non-smoker babies, mothers. Now, this was the case of the independent sample, but it is not so. Sometimes we come across with the situation when it is a paired one. Situation 2, independent mass sample and pair of observation. Assumption is distribution of the difference m1 minus m2 between the pair is not too skewed. It means nearly normal. So we can apply the paired t-test. Examples are serum albumin of 8 randomly chosen patients of dengue fever before and after the treatment. Consider a treatment for blood pressure which is 3 months and after 3 months, before and after the 3 months. Follow-up cases are generally treated as paired data. So this is the assumption. What is H naught? Mu D is equal to 0 versus mu D is not equal to 0. D is the difference between the two means, paired means, before and after. So t-test has got formula T is equal to D bar upon S by N under root, where D bar is nothing but mean of the difference, M1 minus M2. This is the example, SBP while not using OC, SBP while using oral contraceptive. So before it was 115, those who do not, while not using this, was 128 SBP. What is the difference? Difference is 128 minus 115 is 13. So we get the difference of all these mother. The mean of the difference is 4.8, having standard deviation 4.57. So applying the formula d bar upon S by N under root, substituting all these value, we get that it is significant, and 95% confidence interval will be 4.8 mean plus minus 2.26 into the standard error of the difference. Generally we come clinical significance versus statistical significance. If the sample size is very large, then look at the difference. Their temperature is 39.95. The group where the drug was not given, it is 500, and the mean is 40 points. So look at the difference. Hardly any difference, but this is a significant. Why this has come to be significant? Because N is very, very large. Here the difference is 39.95 minus 40.05, which is hardly 0.1 only. Difference of 0.1, and it is significant, which has got no relevance. So be careful while drawing the inference. This is significant because of the large number of cases. If statistically we see, yes, probably there is a reduction in the temperature because it is significant. But if we go by clinical, no temperature, only it fell by about 0.1 centigrade, which has got no meaning in the clinical setup. So we should avoid such things. Then third is when categorical variable has got more than two levels, then one way ANOVA is applied. Its situation, multi-generalization of the t-test more than two, and here overall experimental effect is seen. Assumption population variance in all the group is same, and distribution in each group is normally distributed. So what is null hypothesis here? All the means are equal. What is alternative here? Not all the means are, or any one pair is equal. Now we will discuss about ANOVA. ANOVA is meant for when categorical variable has got more than two levels. First assumption will be the sample are randomly taken, and it should be independent to each other. That means it is not related samples. The two variables is categorical. The independent variable is categorical and contains more than two levels. The distribution of the dependent variable is nearly normal. If the distribution is seriously skewed, then the ANOVA cannot be applied. Try to have some transformation and see whether this assumption is met or not. The groups should have equal variance. These are the various assumptions which we see when we apply ANOVA test. This is the setup of data, how it is entered for ANOVA cases in any software. Analysis of variance is divided into two. The total variation is divided into betweens and within, and F test is applied by between the subject divided by within the sum of square. Then F test we will get. This is the test for ANOVA. This here the mean all are same, all alternative, not all are equal. While applying the ANOVA test, we meet with the source with various variations. The variation can be divided into two parts. The variation between each group means and overall means for all the group. This is called between the groups variability, and the variation between the study and the participant group mean. This is called within group variability. If the between group variability is much greater than the within group variability, then it is likely to be different, then likely to have a difference between the group means. That means ANOVA will give you the significant result. The source of variation comes from two: between the groups and within the group. That is, and we divide this sum of square, we get the ANOVA statistics, F test. Then the example, suppose now one example, suppose we have got three different teaching methods, and ultimately the student is evaluated by a test out of 100 score. So first test is punishment teaching style. Second, no punishment but reward teaching style. Indifferent, neither reward nor punishment is left alone. So these are the three different tests. Here it is more than two, so we apply one way ANOVA. So this is the setup for data. Here N1 is equal to 9, 10, 11. H1 no difference, or mean this is the statistical software output. Here mean is 49.4, 56 and 64. So look at the means. It increases. Type 1 punishment 49, reward 56, indifferent, neither punishment nor reward it is 64. So the one way it is increasing with the time. So and more, look at the p-value, sig is 0.00, it is significant. That means all the three teaching methods are different. As we have seen previously, the p comes out to be p less than 0.001, indicate there is a significant difference between the score among the three groups. Since because this is significant, it says that all the three groups are different to each other. Question rises, from which particular pair has contributed a difference? This particular, to see this particular pair of contribution, we have to apply various t-test, that is called post hoc comparison. Since this is a significant difference in an ANOVA table, now question rises, which particular pair has contributed towards the overall significance? To see this, we test multiple comparison, or sometimes called as a range test, or even nowadays it is also named as post hoc test, etc., etc. So many, there are so many post hoc tests. We have to apply the p-value here because it is significant. We need to go for multiple comparison to see which particular pair has contributed. In statistical software, there are so many methods applied, but that is called multiple comparison, post hoc comparison, also known as post hoc comparison. In case of non-parametric, it is known as probability proportional or multiple range test. So this is the scenario. There are n into n minus 1 by 2 combinations possible. If there are three groups, then three pair of observation are there, as shown by this. Bonferroni, Dunner test, or Shafis are the basic comparison generally used. Then third situation is continuous versus continuous. It is, there are two types of this data, continuous versus continuous. Then Pearson correlation coefficient is the best alternative. If it is ordinal by ordinal, then Spearman rank correlation has to be seen. It is generally known as rho, RHO rho. Example is a person having English and maths marked together, ranked by rank them and have this, then Spearman rank correlation. If data is not normally distributed, we go for Spearman correlation coefficient. Now I will discuss about the correlation. This is the clear-cut case of comparison between the two continuous variable. One is continuous, another is a continuous variable, another is also continuous. Example, age of a boy compared with the weight of the boy. I want to see the relationship, how if age progresses, what happens to weight. Both are continuous variable. So now we can apply correlation coefficient. There are two types of correlation coefficient. First is Pearson correlation. It is meant for normally distributed data, whereas Spearman correlation, generally known as rho, RHO rho, and this is meant when we have got a ranked data on non-normal data. This is the calculation of Pearson correlation. X and Y, two continuous data, say weight and age, and under n number of cases are there, and the formula is given by this: R is equal to summation of xy minus n into x bar into y bar whole divided by variance of x into variance of y. Variance of x is equal to summation of x square minus sum of x whole square divided by n. This way we can calculate the R value. R varies from -1 to 1. This is the example. Here I want to see the relationship of father's height with the son's height. This is the scenario. I have substituted the value. R is equal to this. I found correlation equal to R is equal to 0.602. It is a good correlation but not very good. So generally there is a more than 60% is generally considered as, so here it is good. So that what do we mean? The correlation is the extent of relationship between the two variable. That means height of the son depends upon father's height. That is well known fact, genetics effect. Summary of the statistical test which we have read just till now. The inference can be done by applying an appropriate statistical test. The various statistical tests basically depends on the nature and the comparison of the different variables. The variables are of two types. Either it is a categorical, which cannot be measured, or quantitative, which can be measurable with some definite scale. These are called quantitative. Categorical variables are like sex, color of the hairs, and face, complexion, color of the complexion. Whereas quantitative is age of the patient, weight of the patient, height of the patient, HB of the patient. These are called quantitative because we can measure all these. The variable is generally known as either quantitative variable is known as a continuous data, whereas categorical data is a categorical data. Now the three possibilities are there if you want to compare. Either you compare simple, one sample only. Either if all the data is categorical, you can have prevalence, proportions, or percentages also with along with the 95% CIs. If it is one sample and quantitative data, then mean or standard deviation, median, minimum, maximum, etc. you can find out. If there are two variables under comparison, then three possibilities are there. Either both of these variables are categorical in nature, so you want to compare categorical versus categorical, then chi-square or Fisher exact test as appropriate is the best option. But the second possibility is if it is variable, one of the variable is categorical with two levels and another is continuous with this thing and follows a normal distribution, we can go for t-test. If it is a paired data or matched data, then we will go for paired t-test. But if categorical data has got more than two levels, then we have to go for ANOVA if normality condition is satisfied. Third one is continuous versus continuous, then we go for correlation or regression analysis, which is the best options.